Welcome to Lab 11 for Physics 187. In today's lab, we are going to establish yet another technique for measuring the distances to objects that are very far away from us. You may remember that the brighter an object is, the farther we can observe it, the farther away it can be so that we can observe it. And so we're going to take advantage today of a particular class of stars that are very bright, Cepheid variables, which you may remember from class are stars that are going through the end stages of their life, are actually changing in brightness. And what we've discovered is there's a direct correlation between the period at which that brightness changes and the absolute brightness of those particular stars. When you open virtual astronomy, you will get a view of the sky that will contain 10 Cepheid variables. Some of these variable stars may be quite obvious. We can see this one right here is actually brightening and dimming, and some of the stars may be less obvious, but somewhere in your field of view you should find 10 of these stars where their brightness is changing. If you're unsure if a star is a Cepheid variable or not, if you click on the star and you get a graph that shows its relative magnitude as a function of time, you will be able to know you have a Cepheid variable star. If you click on a star and you don't get anything that shows how the intensity of that star varies with time, that's just an ordinary star. So let me go ahead and pick this particular Cepheid variable star right here and show you what we get. What you are seeing here is you are seeing the light curve of that Cepheid variable star. It shows you that the brightness changes on a period of some time, and it shows you that it goes from a maximum brightness here to a minimum brightness here. And actually this is a little bit reversed because remember, brightness, the smaller the number, the brighter the object. So if you notice down here, the numbers are decreasing negative. So at this particular point right here, with a relative magnitude of about a negative 6.64, this star would be at its brightest, and with a relative magnitude here of about negative 6.04, this star would be at its dimmest. What you'll need to do for each of these stars is determine the average relative magnitude and then determine the period for the star. Much of this will be visible in the bottom here, and notice that right now I can't see anything, but if I go ahead and I maximize the window and then click on my Cepheid variable, I'll be able to see the information on this bottom menu bar. Here are the data that you need to collect. You need to determine the minimum value for the brightness. So you need to move your mouse to this point right here and record the magnitude at that particular point. In this case, it's a negative 6.06. And then you need to find the maximum brightness. So you would go to the lowest point on this graph and you would record the maximum value. I know it's the smaller number, but remember, smaller means brighter. And record the value for the bottom point, negative about 6.65. I'm not quite on there. Make sure you're very careful. All right, so I want to get to the bottom of that point. And so about a negative 6.64. Okay. The top value and the bottom value added together and divided by 2 gives you the average value for the relative magnitude for that star. So that's step 1. You need to find the average relative magnitude by finding the value for the top and the value for the bottom, adding them together and dividing by 2. There's a useful little tool in the spreadsheet that will help you do that. The second thing you need to find is you need to find the period, which is the time between when the star reaches an identical brightness. So what I would do is I would measure the time between this top peak here and this other top peak here. Right? And again, if I move the mouse so it's lined up with this peak right here, it will tell me when that particular value for brightness occurred at 14.64 days. And then I move over to this peak, and it tells me that this occurred at 29.23 days. So if I take the difference between those 2 days, I get the period for this Cepheid variable star. Those are the measurements you will make for each of those 10 Cepheid variables. The top and bottom value for the brightnesses, which you will average to get the average relative magnitude, and then the peak and the peak to get the period for that particular Cepheid variable. Now, how do we use that information to actually find the distance to that Cepheid variable? Well, astronomers have discovered a relationship between the period and the brightness. There's a graph in your lab manual, but as always, if you have a graph and a line that relates the data, you can create a formula for that line. And so the relationship for Cepheid variables says, if you know the period and you want to find the magnitude, you just simply put it into this equation. You take the log of the base 10 of the period, you multiply it by this constant, and then you subtract that product from this negative value right here, and that will give you the absolute magnitude. Once you have the absolute magnitude and you have the average relative magnitude, you can take the difference between these two, add 5, divide that by 5, and then take 10 raised to that result. This is the same equation we used last week when we were doing spectroscopic parallax. We're just finding the absolute magnitude now in a different way. We're taking the fact that we know Cepheid variables have a relationship between their period and their absolute luminosity. Let's just take a quick look at the spreadsheet to see how it's set up. These columns right here are where you'd record your value, your period, and your relative magnitude. Your absolute magnitude will be calculated. If you click in this cell right here, you will see that we use that equation that we just talked about previously. And if you click in this cell right here, you will see that we're using the distance equation. This box down here will help you calculate the values that you need to put into this particular box right here. So if you put in the first time and the second time, it will give you the period by taking the difference between those two. If you put in the minimum and maximum value, it will find the average that you would then move up to here. The one place where you may run into issues, let me just take you back to a particular Cepheid variable. So if we look at this particular graph, it's not immediately obvious because the period is so long that we're actually seeing a full peak. If you encounter a situation like this where you don't necessarily see two peaks, what you need to do is just remember that the period represents the time between two identical places. So for example, if I go to this point right here, it tells me that this point, you get just a little bit closer, that when I start right here, I'm about at 0 days and a magnitude of a negative 8.39. If I move over to here, this peak is also at a negative 8.39. So what I've done is, even though I can't quite identify that this is a peak, I've realized that this is at the same value at that, and so this truly then, because I'm starting at 0, this actually represents the period for this particular Cepheid variable. On occasion, there may only be 9 stars. If that is the case, then just simply report your results for the 9 stars. You need to check your answers for each of the 10 Cepheid variables. So you have one box that you need to screen capture for each of these 10 Cepheid variables. Again, when you click on the Cepheid, it will tell you which Cepheid it is. For each of the 10, enter the period, enter the average magnitude that you would have calculated by looking at the high and the low. The absolute magnitude is calculated from the period, and then the distance in parsecs is also calculated in your spreadsheet. As always, the spreadsheet does most of the work for the 10 stars, but you have to provide me with one sample calculation where you show me that you know how to use the numbers to find the distance, the period, and the absolute magnitude for those stars. Good luck with the lab. If you have any questions, please email me.